I'm really delighted to welcome Ingmar Weber, or actually Weber, as he corrected me, as his mum would say his name. I first came across his work back in 2010 with a paper that some of you may have read too, about the demographics of web search. And at the time, I was working on contextual relevance at Bing. And for me, this was this beautiful example of really thoughtful research examining how demographics, in this case recorded through the US Census, could be intersected with search data to give us deep insights into how different groups of people actually interacted with the web and with search more generally in ways that were unique. And it sort of echoes some of the discussions we've been having over the last day or so. I'm sort of mindful of Paul Thomas's paper talking about how the crowd is actually made up of people, and that's also true in so many other ways. That what we really love thinking about this at Cheer, that it's not just a whole mass group of people, it's in fact individuals and how they are different. So just some background then on Ingmar. He's the research director for social computing at the Qatar Computing Research Institute. His interdisciplinary research, which again we love at Cheer, looks at the kind of online user-generated data and how that can tell us about the offline world and society at large. He's worked closely with sociologists and demographers, and in doing so, he's pioneered this use of online advertising data for complementing official statistics on international migration, digital gender gaps, and poverty. All super important issues, certainly at this current time. His work is regularly featured in UN reports and analyses performed by his team, been used to improve operations by UN agencies and non-government organizations, ranging from Colombia to the Philippines. Prior to joining QCRI, Ingmar was a researcher at Yahoo Research in Barcelona. And as an undergraduate, he studied firstly maths at the University of Cambridge before going on to obtain his PhD at the Max Planck Institute for Computer Science. And recently he was recognized through all of this amazing work as an ACM distinguished member. And I remember seeing that email come in, I was like, wow, that's so cool. Being recognized at this level is a huge achievement in ACM community. In terms of the keynote, I think it's up pretty much already, so you can see it. The title is Built for Profit, Repurposed for Research, Using Advertising APIs to Collect Social Media Data. And Ingmar's promised that we're going to have both a thoughtful and provocative talk that'll hopefully spur on many questions at the end. So Ingmar, please take it away.
Yeah, thank you so much for the introduction, Peter. And there's a direct through line from this first paper on sort of demographic of web search to this to the work that I'll be presenting today. And hopefully, again, the presentation will be provocative, or at least make you a bit feel uncomfortable in a sense, right? About what sort of you can learn about big data and just how much is being collected. And happy to discuss it then more at the end. So the work that I will be presenting is joint work with a number of people. So here at QCI, there are my colleagues Joao and Masumali. At the University of Oxford, there is Ricky Kashyap. There are a number of other people, just to pick out one name. There's also Emilio Zacchini at the Max Planck Institute for Demographic Research. And he got interested through our work, sort of demographics of web search on how, what other types of research or demographic research can be done with big data. And so on. I've been fortunate to work with Emilio now for more than a decade on these topics. So let's start with a slogan that you've probably heard before, right? So if you're not paying for the product, then you are the product, right? And so, for example, Facebook and other social media sites are free, in quotes, right, to use, right? And again, you pay through your data, right? So Facebook, for example, would collect a lot of information about you, and then they use it to build up sort of user profiles, and in particular, they would assign certain attributes to users, right? And then advertisers can use these attributes to target their ads. Right? To give you like a real example, right? I can go to Facebook and say, okay, I would like to launch an advertisement campaign and have my ad only be seen by female Facebook users living in London, age 25 to 29, who lived in Poland, right? That's already interesting. There's some sort of migration background, and to use an iOS device, right? So fairly specific, right? There's maybe a lot you can sort of, infer about it, right? And then the crucial thing for this talk is that before you launch your advertising campaign, And before you have to pay anything, Facebook provides so-called audience estimates, right? How many people match your targeting criteria, right? So in this case, Facebook would tell you upfront, before you launch your campaign, that there are 2,600 monthly active users or MAUs matching your criteria, right? And furthermore, these user estimates can be nicely collected, easily collected through for free through APIs, right? So you can sort of set up collection of how many users match certain criteria, right? So this, in essence, creates a no-cost real-time census over just about 3 billion Facebook users. And it's also not only Facebook. I'll later also mention a bit LinkedIn and sort of other platforms, right? But you can sort of ask how many social media users match certain criteria. You get an answer in real time, for free, right? And so the question is, okay, in my research, the question is so what does such data tell us about society? But actually, I want to show you this data live first. So I'll quickly go to a different window to share, just to make it very sort of concrete what is sort of available through these sources. So what I'm sharing at the moment, and hopefully you can see this, is Facebook's advertising platform. So I hope you can see something that says sort of San Cristobal in the middle. So here I'm at the step of selecting my audience for my advertising campaign. And so far I've selected Facebook users living in Norte de Santander. This is part of Colombia, so the country of Colombia, which is on the border with Venezuela. So Venezuela is here in the east, on the right. And so far I've just selected as of age 18 and above, so very generic, all genders, everything else sort of very generic. And then here on the right, you see what I was referring to before, right? So here you see the estimated audience size, right? So this is the number of sort of monthly active users who match my targeting criteria, right? So let's use this upper number for now. So about 1.2 million people match my targeting criteria, right? But now I can be more specific, right? So for example, I can look at how many of these 1.2 million Facebook users used to live in Venezuela, right? Sort of the neighboring country, right? And you see now, it's there's still a pretty large number, right? Like sort of like maybe 1/6 or so, or slightly less, of people here are sort of used to live in Venezuela, right? But I can drill down further. I can look, okay, how many of these are women? Okay, roughly half. And then if I wanted to understand their socioeconomic situation, there's not direct targeting by income or so, but I can look at the devices they use, right? Like, some devices are more expensive than others. And I can, for example, just to keep it very, very simple, just look at how many, of these sort of women from Venezuela are using iOS devices, which are typically more expensive than Android devices, right? And you see it's a fairly small percentage, right? And so, okay, so what can you sort of do with these things? I'll show you some data visualizations we've created around such data. So this is what you see here is, of course, not Venezuela, it's not Colombia. This is a city of New York. And this is not data from today, it's data from, I think, 4.5 years ago, right? So let's imagine you didn't know anything at all about this city here, and you wanted to understand, let's say, a wealth distribution, right? So then you can look at, okay, where in the city is the density highest of iOS devices, right? And you so you see here, this is Manhattan, Midtown. You have about 90% of Facebook users collecting through iOS devices, right? But on the other hand, so here in the Bronx is only about 40 to 50%, right? So you would correctly assume that there's a wealth differential between these two areas, right? Like so and in this case, of course, we know that that's true. It's not an artifact that this is really true. Or if you wanted to understand sort of migration background, you can look at people who used to live in Latin American countries. Where's the density highest? And again, sort of here in parts of the Bronx, you have sort of, about 40% of Facebook users who previously used to live in Latin American countries, right? Sort of, right? And so again, this is again, sort of, matches sort of the real world. Now, in this case, there's very good open census data, open government data. I'm not telling you anything you could not find out through other data sources. So this is just a toy example, right? But in other parts of the world, you don't have open government data, right? This includes the city where I'm at the moment. So here we don't have zip codes. So this is where you sort of target through sort of latitude, longitude, and with a radius. You don't have these sort of nice areas, right? And let's say, okay, suppose you wanted to understand the sort of general situation of migrant workers from Nepal, right? And so first, you can see which part of town they're in. So their density is quite high in the industrial area. Now, again, we don't have ground truth for this, but if you search on Google industrial area Qatar, you would see that this area was built to house people from South Asia, right? And so it's really true and matches my observation. A lot of people from Nepal are in this area, right? Furthermore, they're almost all men, right? These are sort of construction workers that don't make the minimum income to bring over the family. There's a certain income threshold to get a family visa, right? So they're almost all single men who are in the country. They're fairly young, which is a blessing during COVID-19 because all of them have been affected. I mean, like, you know, the vast majority, but only very, very few have actually sort of died as a result from that, right? Because they're generally young and healthy people, right? And almost no iOS users, right? Like only sort of less than sort of 6%, right? Sort of, right? Now I can contrast this with people such as myself from Western Europe or North America. I mean, so I live in a completely different part of town, right? This is literally where my home is, right? Not sort of coincidentally, right? Sort of, so I hardly ever go to this other part of town, right? It's roughly gender balanced. I'm here with my wife and family. A lot of university grads, right? You have older people. I'm still on this side of the threshold, but you know, you have a lot of the sort of, you know, knowledge experts, and you know, you have more iOS users than Android users, right? There's much higher disposable income, right? So you know, in broad strokes, you can get a pretty good insight about sort of, you know, sort of structures of society, right? And again, potentially you can do this for anywhere in the world. I'll just show one other example. This is now data from Lagos. This is a bit more recently. I think we collected this sort of last year. Again, let's look at sort of wealth distribution. So if you look at where the density is highest of iOS users, this is Lagos Island. This is where the government is located. And so here you have about sort of 15% of iOS users. Again, this is the seat of the government. And then, you know, in sort of in the rest of Lagos, it drops to about half of this, from 15% to about like 7% or so. Then the outskirts, it drops sort of further, right? And so based on this, you would probably correctly, but now it's already more iffy, right? Because there's now not necessarily ground truth to validate against, which is sort of the whole point for doing this, but you would probably assume that there's a wealth differential between these two areas. Now, this is all derived from Facebook data, right? And Facebook is, you know, still the biggest social network in town, but there are other data sources out there that have similar platforms. Basically, anything at all that has targeted advertising has a platform like this. So I'll just very quickly show LinkedIn sort of as well. So here, again, same thing. I go to LinkedIn's advertising platform, right? I would like to show an advertising campaign to people living in Bavaria, right? Sort of so, only to female LinkedIn users who have the skill artificial intelligence, right? Whatever that means, or sort of or so. And so now it tells me this sort of the size of the audience segment up here. And then just to add one more thing, which I think is also quite interesting, you can look at a social network connection. You can look at of these women with the skill artificial intelligence, how many know somebody who's currently at, let's say at Amazon, right? Sort of so, right? So you can sort of map out sort of social networks, sort of so. And of these, it also tells you most of these women matching are currently in engineering or sort of so, right? So just to give you like a sense of what you can sort of do with this data. So with this, let me continue with hopefully this made it very concrete and again, I mean, now I did this by hand, but there are APIs to automate all of this, right? I mean, you sort of so you don't have to do this, of course, by hand, right? So again, so here, I mean, I'll make sure that the slides are available, sort of so there are very well documented APIs and also nice wrapper on top of this. So a colleague of mine spent some time at the World Bank and created nice wrapper APIs, both for the sort of Facebook and the LinkedIn data collection. And so, okay, so just sort of look at, so what sort of data can you collect, or rather what sort of targeting attributes are available? So some things are self-declared, right? Like sort of, so for example, on Facebook, you know, you declare age and gender, sort of, so this is the most basic that is required. You must do this when you sort of sign up. Then other things are sort of optional, right? And are sort of fuzzier, right? Sort of education level is self-declared and is often missing, but, you know, often also there. Hometown is self-declared. In a sense, your friends are self-declared, right? Like sort of so. And LinkedIn, again, sort of so. And the most basic thing is employment history, but then again, you can sort of add your sort of social network and sort of skills and other things. Now, then there are other things that are sort of derived from your our metadata, right? Like how you interact with the platform, right? So for example, your device type, if you use like 4G, if you use an iOS device or not, also how you connect, whether you use Wi-Fi or 4G, sort of so. Right? This you don't declare, just sort of, you know, automatically inferred from your through your sort of interaction with the platform, right? And similarly, your location, right? Like either based on your GPS or based on your IP address, right? Sort of, so at least the platform knows certainly which country and typically city or even sub-city you're in, right? And similarly on LinkedIn, you can sort of target, for example, people who are frequent travelers or people who connect on a desktop versus sort of mobile. And then there are these inferred things, sort of, right? This is now where sort of AI and machine learning sort of comes in, right? So Facebook somehow, and we don't know exactly, right, somehow infers your home country, right? Like sort of so, and certainly it's based partly on your hometown, but we believe there are also other signals that go into this, including your sort of social network, right? Somehow they infer your interests, right? They believe what they have an understanding of what you're interested in. Again, this is inferred. You don't explicitly declare your interests, sort of also, right? You just like certain things, you follow certain pages, sort of also, right? On LinkedIn, actually, you don't declare your age and gender. These are inferred, right? So this is, again, noisy and will have sort of biases. And again, it's all sadly only binary, but that's what the spy would sort of use. Also, things like such as your seniority are sort of inferred based on your sort of job title, right? And also if you are like a job seeker or not might be inferred, right? And just to mention, so this is now this inference in particular of interest. This is where most of this sort of tracking comes in, right? Like when you read about sort of like, iOS limiting what Facebook and other sort of platforms can sort of access, right? This is what's most being affected, sort of. So the other things are not directly affected, certainly not as much, right? But in most of my work, we actually use the other things, or sort of. So although we have also started to, we've done some work looking at the interest. Again, just some homework if you're interested in, well, what do these platforms actually know about you? You can look that up. This is like, I think there's even a legal requirement for these platforms to make that available, sort of, or so. And I'm just showing the links here. And again, I'll make the slides available so you can, at your own leisure, sort of look up, hey, what does Facebook believe about me? And some things are sort of true and amazing. Oh yeah, that's true. And other things you go, why would Facebook ever think that, right? Like sort of, so it's certainly, you see that these are not, perfect, sort of, wizards or something, sort of, but some things are actually quite impressive. So it's a mix, sort of. So there's a lot of noise, but also things that you might go, wow. Right. So now in my own work, so I now use this data to fill data gaps on international development, right? And so there's now sort of like a topical shift, right? So now we get to the application. So what do you do with this data, right? So or rather, what's wrong with existing data on international development? Well, there are at least sort of three things where it's lacking. So one is sort of update speed, right? So in the international development world, the most important data set, I would say, is sort of the census data, right? So this is done sort of every sort of 10 years. It's very, it's a complete enumeration. Every person is supposed to contribute, or sort of, so it's very, very accurate, right? But it's done once every 10 years, right? Like how can you run a company, let alone a country, if you have data that's, sort of completely out of date, right? So update speed, right? Now think of, what's going on during the pandemic, right? Like if you have data from the 2010 census, like what do you do with that, sort of, right? Sometimes it's spatially very coarse. So you might have one data point for Uttar Pradesh, which is a state in India, but Uttar Pradesh has 200 million people, right? Again, there's 200 million people in one state, right? So if you know one data point, what does that mean, right? It doesn't mean anything, right? And even if it's spatially disaggregated, it might not be demographically disaggregated, right? You might have, for example, things such as like household level income, but in some countries, right, maybe the household has access to assets, but it's only the male, often typically, male head of the household that controls everything, right? And the sort of the situation of his wife or other sort of family members, right, might be very different, sort of. Right? And so how can you sort of do some demographic disaggregation, right? And so in a nutshell, that's what we sort of try to complement, right? We try to improve sort of recency, we try to improve sort of spatial granularity, and we try to improve demographic disaggregation by using these things. To make this a bit more concrete, so in the rest of my talk, I'll talk about three specific projects that we did over the last couple of years. So one looks at international migration, in particular, from Venezuela. One looks at mapping poverty, and one looks at tracking digital gender gaps. Right. So the first project to talk about this was joint work, in particular with UNHCR, UNICEF, and an NGO called IMAP, that is sort of information management in the humanitarian sector. So. Right, so Venezuela, probably you heard about what was going on, still is going on, right? There's this huge sort of economic and humanitarian sort of crisis. Just to show you some numbers from sort of 2019. So according to the International Monetary Fund, in 2019, inflation was at 10 million %. It's not a typo; it's really 10 million %, right? So this is as hyper as hyperinflation can possibly get, right? Again, these are official estimates or from the IMF on unemployment upwards of 40%. If you were earning minimum wage and spend every single, I think it's peso on food, you could only afford 1,000 calories a day, right? You were literally sort of starving, right? So this is also sometimes called the Maduro diet, right? So somewhat cynically. As a response, a lot of people have left, right? Upwards of probably 15% or sort of of the population, mostly into neighboring countries such as Colombia, but also other countries in sort of South America and even sort of, other parts of the world. But how many and what type of people, again, this is sort of, as often is the case in sort of this migration crisis, is not, it's not known sort of, right? So data is often, in aggregate and, sort of missing, right? So, okay, so what does Facebook tell us about the situation, right? So here, I'm showing data that we were collecting over time from Facebook. So let me try to walk you through slowly what you sort of see here. So let's first only look at data in red. So this is now for the host country of Colombia. So the origin country is always Venezuela. So we're always looking at people who used to live in Venezuela and are now living elsewhere, right? So this can look at people living in Colombia. So that's what's shown in red. The lower range of this sort of bar is just the raw number of monthly active users who used to live in Venezuela and are living in Colombia at the time, right? This is sort of what I showed you before for just even part of Colombia, right? You would sort of conceptually go to the interface, in June 2018, you would look at how many people used to live in Venezuela, living in Colombia, and sort of you would write down that number. Of course, you do that automatically through an API, right? Now, this number is probably an underestimate, right? If we assume that there are no false positives, if we're assuming that there are sort of only false negatives because either people, so in particular because people are not on Facebook, then we are missing basically sort of the people not on Facebook, right? And so we make an assumption that the Facebook penetration among the Venezuelan migrants is the same as the Facebook penetration in all of Colombia, right? So we look at what's the total population in Colombia, what's the total number of Facebook users? Let's say it's 60% penetration. So we're missing 40%, right? So we're sort of adding now sort of 40%. This is a guess, right? Sort of like a guess, sort of to correct for non-Facebook users, right? Right? And so this is, but probably this is closer to the truth than this value, right? Like sort of, right? And then basically we're sort of monitoring this over time, and we're doing this sort of for different countries and different sort of also at the sort of regional level for all of Latin America, right? Now the question is, okay, how good is this data, right? Like sort of, so is this random, people, whatever, maybe, I don't know, Facebook gets it wrong or sort of, so let's compare to sort of official statistics, right? Like again, and this is sort of like gold standard in, double, triple, quadruple quotes sort of, so again, because like this, the whole point is that migration data is often quite poor. So here you have data from two different UN reports across two different snapshots. So first you'll see that even within the same sort of broadly defined organization, they come up with different estimates, right? Depending on sort of the methodology used, sort of, so right. That's also quite common. But then at least they're sort of broadly in line with what Facebook would suggest, while Facebook would probably suggest an even larger number, which again is not implausible, sort of, so that these are probably under estimates, right? Ultimately, we don't know for sure though. Let's try to do more validation at a sort of subnational level. So here I'm showing, so this is now data for Colombia. Again, the host country is Colombia. On the left, you have data from the Colombian government that was collected in sort of April to June 2018. And on the right, you have data that was collected around the same time from Facebook. Now, this data on the left was collected through voluntary self-registration. Basically, sort of migrants and refugees were asked, please come and register yourself, we'd like to sort of count you, right? And you can sort of imagine that for whatever reason, people might be hesitant, or they might not exactly know what does this mean for my long-term legal status, or sort of, right? Now, still, if you compare these two, there are some similarities, right? Like on the border, they're certainly sort of both pick up, a large number, but then Facebook would suggest a larger number further away from the border, right? Now, it's a question, so who's right, who's wrong, right? So because we were actually working with people in Colombia, they actually told us, you know what? This looks much more plausible. By this, I mean sort of the data from Facebook looks more plausible what we see on the ground, because we also know that the self-registration efforts were more pronounced on the border, right? The sort of campaigns about please come and register, sort of. So it's kind of like most pronounced where people literally enter the country, right? But many of them don't stay there, right? I mean, this is also we just see, in let's say current situation in Ukraine. I maybe talk about more later, sort of. Where people don't stay at the border, of course, they move further inland, sort of. So but there you might be missing them, later, sort of. Right? And so punchline again, we don't know for sure, right? I can't give like a very formal R squared or sort of so because the ground truth is really, really bad, which is kind of the whole motivation to do this work in the first place. But again, people on the ground would sort of probably suggest that the data on the right is closer to the truth than the government data. In other countries, we don't have subnational data to compare against. And so again, this would be the only sort of available data source that we are aware of to paint a subnational picture of the situation. Here, just to mention Brazil, actually, the fact that they were also Venezuelans a bit further south actually had operational impact on UNICEF. So UNICEF was running an anti-xenophobia campaign where initially they were only targeting the northern part, but then based on our analysis, they also included the southern part, in their campaign targeting. Now these broad numbers are nice, but you can actually do more than the broad numbers. You can try to get insight into the socioeconomic situation, right? I'm going to refer to this the device type before. So okay, so what does this graph show you? So every bar is again a host country or host region. So we're only looking at people from Venezuela, but for example in Argentina, right? So always from Venezuela. Now the order of these bars is by the percentage of iOS use. So let me explain. So for example, people from Venezuela who were living in Roraima, Brazil, which is the jungle, you basically walk across the border, it's hardly any iOS users, only 3% were using iOS devices. On the other hand, people who make it all the way to the United States, there you actually have a majority of them are using iOS devices, right? So 54%, right? And this would already tell you probably people who make it all the way to the US in general, right? Not at the individual level, but in group level, they're of lesser concern than people who walk across the border in the jungle, right? I mean, maybe it's obvious, but again, you should quantify this. And then anything in between, right? Now, the height of these bars, again, we try to put a dollar value on it. Maybe that's a bit too ambitious, but basically what we do is we train a regression model that predicts country level GDP per capita, right? So for example, we predict what is the GDP per capita in Chile? What's the GDP per capita in Curacao? What's it, etc. And this model uses only a single variable, right? It only uses the percentage of iOS usage among Facebook users in Chile or in Aruba and all these other countries. Now, just with a single variable, right? If you just tell me the percentage of Facebook users using iOS devices, I can explain almost 90% of the variation in per capita GDP, right? It turns out to be a very, very strong predictor. And now this model that's now trained to predict country level GDP is now applied to these different subgroups to get like a equivalent, right? Like if these people were a country, right, it would be a country of a per capita GDP of maybe $4,000, right? So just looking at their iOS usage. Now, the precise dollar values will probably be noisy, but we tried different model specifications and try different things, and we always find at least these three groups that are robust. So we are quite confident to say that people who are basically staying in the neighborhood, so to speak, so they are worse off than people who already go a bit further, but still in Latin America, and then people who make it all the way to Europe or the US are of least concern. Right? Again, but it's interesting. We can do more than just numbers. We can also try to get a sense of socioeconomic situation. Again, we were happy that this went beyond just an academic paper, but it continues to be used through a partnership with IMAP, who's also using this data together with USAID, right? And it's also nice for us because for us, capacity building is important, right? It shouldn't always be me doing this analysis. It's great that now they continue to do this analysis independently. Now, it's not all good news. I also, want to show some of the caveats and some of the things that we were stumbling over. So here I'm showing you a screenshot from a dashboard we were building for UNHCR and others, where we're basically looking at these trends, every other week or so, right? And you see, this is in this case people from Venezuela in Brazil, and you see this sudden dip, right? This number right, and you wait, what's going on there? Is this like return migration? Is it people continuing onwards from Brazil to, I don't know, Argentina or something, right? What's going on, right? Well, it turns out that at that point, Facebook changed their algorithm, right? So that they just changed somehow how they detect or classify or label somebody as having lived in Venezuela. How do we know? Well, we know because we collect this data regularly globally, and we saw the change at exactly the same point for all sorts of people, right? People from Germany, in Qatar, from whatever, right? Like all around the whole globe, around the same time, all the numbers had a discontinuity, sort of, right? Like, and so then we are fairly certain, right? There's no reason that, you know, the whole world sort of suddenly moved in sort of March 2019 or sort of, right? And so again, this shows one of the limitations, right? I mean, we were sitting on top of a black box. First, we don't know how the black box works, right? That's already a limitation. But then on top of this black box might not even be stable across time, right? I mean, they have no obligation. They don't have to inform us anything, right? They just changed, oops, right? And now it's a new number, sort of, right? And we have to sort of deal with that, right? So this is, of course, a key limitation, sort of in this sort of work. Great. So the next line of work, I'm just giving an eye on time, is so far so good, is on mapping poverty, right? Basically, sort of elaborating on this idea, sort of the device type. What else can we use? And this is a joint work with UNICEF and also a data science company called Thinking Machines, based in the Philippines. Tiny bit of background on sort of you know, poverty mapping. Why is this, you know, relevant? Probably most of you have heard of the sort of 17 Sustainable Development Goals. The first of these sort of, you know, high and lofty goals is no poverty. Right now, okay, what's the definition of poverty? There are different definitions. So the UN mostly uses a monetary definition that looks at sort of income, where you would define you as extremely poor if you make less than $1.25 per day. Now, if you look at the most recently available data on poverty, it's often quite outdated because, again, it's mentioned sort of to the census that's done every 10 years. And then it still takes often like 1 or 2 years for the census data to be processed, right? So in many parts of the world, again, you have sort of poverty data that's now 10 years old or so, right? And even when it's available, it's not necessarily spatially very fine-grained, so to speak, right? So, okay, so we sort of basically try to sort of fill data gaps on this, again, using data in particular from Facebook. So in this case, what we try to predict is not monetary poverty, though, but asset-based owner poverty. So we are using data from a USAID. They have this demographic and health survey wherein they go to households, right? They knock at people's doors and ask, okay, how much stuff do you have, right? And they would ask, do you have a fridge? Do you have running water? Do you have a motorcycle? Do you have a mobile phone? Right, so they ask all these questions. Then, you know, they compile all these answers using principal component analysis into a single number, where a large positive number means you have a lot of stuff, a large negative number means you don't have a lot of stuff, right? And this is the so-called sort of wealth index, right? And so we try to predict the average wealth index for a given location, right? Do people in this area generally have a lot of stuff, or do they not have a lot of stuff, right? That's sort of what we try to predict. We try to predict this using data from Facebook. I mean, in particular, again, sort of using iOS device users and other things, but also just the Facebook penetration. So if you tell me there's an area where, I don't know, the majority of people are on Facebook, typically that's an area that's, you know, better connected. Of course, that's one important thing, but then also, you know, sort of typically financially better off, right? If you tell me an area there's almost nobody on Facebook, that would probably go the other direction, right? And then, you know, so you have sort of some sort of ground truth data sort of for certain locations, right? You have sort of your features. It becomes a standard regression model, right? So there's no innovation here. You can use whatever regression model you like. Turns out gradient boosting machines work best in our experiments, but again, there's no innovation on this point. Just standard off-the-shelf sort of regression task. Now, how well does it actually work? So then, of course, well, how does it well compare to what, right? Like, is it a difficult task or sort of? So let me try to walk you through this table. So first, we did this in both the Philippines and in India. So far, we've only done this in these two particular sort of countries. Now, as a baseline, let's look at this, which is interpolated DHS wealth index. So basically, here we just look at your closest surveyed neighbors, right? We don't know your value, but some other, you know, locations around you have been surveyed. So we just basically average those and predict your number, sort of. Right? So if everybody around you is poor, right? If all the neighboring villages and cities are poor, probably you're also poor, right? And similarly, sort of, if in the case of rich, right? And that already works quite well, sort of. Right? So in the Philippines, that explains about 50% of variation. This is out of sample variation in this case of the sort of wealth index. In India, it performs even better, right? That means, in particular, in India, there's a lot of spatial autocorrelation, right? Sort of. So that generally all the poor are clustered together, all the rich are clustered together, right? If we now compare this against the model that uses these Facebook features, you'd see that in the Philippines, we improve on this, right? We improve on the sort of the trivial autocorrelation, the spatial autocorrelation. In India, we don't, right? And then if you sort of combine things, also you throw in a regional indicator where maybe the poverty dynamics in, let's say, the state of Kerala in India are different. So then, so if you combine everything, you sort of do even better. And then if you also bring in the sort of the neighborhood-based things, you sort of do even better, right? And so overall, you explain the more than the majority of spatial variation in this wealth index. More so because the ground truth is again sort of noisy, so. And so first there's sample noise, and we estimate that using sort of bootstrap sample. And then there's also deliberate noise in the ground truth due to spatial perturbation. So basically, to protect privacy, DHS doesn't tell you the true sampled locations, but they perturb it up to 10 kilometers. And we sort of estimate how much that matters through simulation. Anyways, punchline being, even the ground truth sort of only predicts about sort of 84% of itself, if that makes sense. I'm happy to elaborate that, but this is kind of like an upper bound just to sort of due to noise in the ground truth, right? So if you compare these numbers against the ground truth, it's actually not bad. Again, like, so there's sort of 3/4 or so of the explainable variance across space is explained by these models. But then more than this, again, we're interested in the sort of demographic disaggregation, because that's something that's harder to do also with satellite imagery and sort of other means, right? And so here, now we have a model that's trained using no demographically disaggregated ground truth, but it just looks at, well, if Facebook penetration is such and such, if iOS users is such and such, then this is the sort of wealth index. But now we apply the same model only to the subset of Facebook users who declare that they have a university degree, right? Or to those who declare explicitly they don't have a university degree, right? So even though, again, so we don't have demographically disaggregated ground truth, right? And so here in this graph, every dot is a location, in this case in India, right? Right? And for this location up here, we would predict that if you have a university degree, then your wealth index is upwards of 200. If you don't, it's below 200, right? And so this is the area where we predict more educated people are better off, and this is the sort of locations where we predict more educated, less educated people are better off, right? And at least the general trend makes sense, right? By and large, we predict if you have a university degree, that's positive concerning your wealth index, right? But and maybe there's some interesting outliers to look at if there's noise or if there's actually something going on, right? So this is at least plausible. Again, we don't have ground truth to validate against, but at least it's a plausible pattern. Now, if you do the same thing for gender, right? So if you're just looking at men and women separately, we get something that's not plausible, right? Because so now we basically see a graph that suggests gender equality by and large, right? There's some noise around the equality line, but overall, we would predict the wealth index for men and women is pretty much the same, right? Now that doesn't really make a lot of sense in the Indian context. So if you look at data from the Global Gender Gap Report, it's something that the World Economic Forum puts out, right? It ranks India 149th out of 153 countries in terms of economic participation and opportunity, right? So there are huge gender inequalities in India, right? I mean, there's sort of nothing. So how can it be that we, in our model, predict something that's not even, doesn't have any plausibility, right? And so what's going on here is the so-called Jackie Robinson effect. So it's a type of survivorship bias. So Jackie Robinson was the first African-American to play in the Major League Baseball, right? And for him to make it, despite all the systematic racism, he had to be exceptional, right? Otherwise, no coach would have picked him over another white guy who's just as good or sort of. So he had to be exceptional to even be to be considered, right? And so then if you were then to extrapolate out from all the from him or the other few African Americans who would come after him, I think, they're all amazing baseball players, right? I mean, all African Americans must be, right? Because all the ones I see are, right? But well, I mean, they need to be exceptional, to make it, right? To be visible, right? And so the same thing happens in India. So there are very few women on Facebook to begin with. But those women that we do see are exceptional, right? They are far more likely than men to have iOS devices, for example. Or they're far more likely than men also to have university degrees and other sort of things, right? We just see the elite in a sense, right? And if we then our model kind of extrapolates out from them, right, to the general public in a sense, it then is completely misled, right? And so if we now go back and adjust the features we use and say, okay, let's not use iOS. That doesn't, we have to think about better how to scale that. Let's use only at Facebook penetration as a single feature, which is also predictable, but not as predictable as all the features combined. Then we get something that's more plausible, right? So now we would, in every single location, predict that women, are doing worse economically than men, right? And that's at least at least the general trend is plausible, right? Like sort of so. And so again, just sort of to mention this as an issue that sort of you get when dealing with these sort of data and the sort of the biases that can creep up. Again, we're happy that it went beyond a paper sort of so this data continues to be used, also independent of us, which is important for us. So that in particular, this company Thinking Machines is using this features together with other features in their work on poverty mapping that they're doing also for UNDP. So we're happy that there's some capacity building that comes out of this. The last, I think it's okay for time. The last example I want to briefly mention looks at tracking digital gender gaps, right? Sort of looking at the male-female sort of discrepancy in terms of users and what we can sort of learn from that more broadly. So I mean, in a nutshell, women are at a disadvantage globally when it comes to internet access. You have two statistics. So in Iraq, for every 1 woman with internet access, you have 2 men with internet access, right? So but both Iraq and similarly also Niger are sort of positive cases because at least they collect and they report this data, right? At least we know where we stand. We can monitor progress, right? Many countries don't collect or don't report this data, right? Sort of to show this, and so to address this, we've sort of, in a collaboration with the University of Oxford, we've created this portal called digitalgendergaps.org. To show this sort of data gap, what I'm showing you here on the platform is data from the ITU, the International Telecommunication Union. This is the UN body that looks at official statistics reported by the member countries on internet usage. The thing that is being plotted is the female to male ratio of internet users. So value of 1.0 basically is gender equality. Value smaller than 1.0 means that women are at a disadvantage in terms of internet usage, right? So first you'd see some patterns that are maybe expected, maybe not, right? So most of, Western Europe and US are doing well in terms of gender equality as far as internet access goes, right? There are many other dimensions, but as far as internet access goes, other parts of the world, not so much, right? Or in particular, so in Africa, where we have data, there are sort of gaps, but then there are also many countries that don't report this, right? Even Canada is not reporting, India is not reporting, right? Like large parts of the world are sort of missing, right? And so this is now where we come in. So this is what you see now is our predictions, right? So these are now predictions derived from Facebook usage, right? So we basically train a model on the countries where we have ground truth data to make predictions for the countries where we don't have ground truth data, right? And we would sort of now predict that, for example, in India, there's roughly sort of 2 women for 3 men with internet access, right? And so how does it work and how well does it work? So okay, let's just quickly look at some sort of different models. So here on the left, you have a model that, apart from a constant, uses only data from the Facebook gender gap. So Facebook gender gap is just the ratio of female to male Facebook users, right? Sort of basically, there's only a single variable apart from the constant, right? Sort of so on. And this explains about close to 70% of sort of the variation across sort of countries, right? So it's already doing quite well. Traditionally, you would use a model like this, right? Sort of so this could use things like GDP per capita and other values from the global gender gap report on sort of what's that I sort of showed you before, right? Sort of so like are women generally at a disadvantage in terms of economic participation? But this model actually doesn't perform as well as the Facebook only model, and furthermore, it cannot make quite as many predictions because this data is not as widely available as data from Facebook. And then if you combine the two, you get a model that in terms of performance is even better, but now you need sort of 2 data sources to be available. So the number of sort of countries you can predict drops further a bit, right? But overall, this is very, very good performance, I would sort of claim. Again, we're happy that this also went beyond the paper and is now part of this SDGs Today portal, where there are only 3 data sources on gender gaps. 2 come from the UN themselves and 1 comes from this project. So we're quite happy about that. At the moment, we are expanding this work to also do this subnationally. So I showed you sort of country level maps before. So now we're doing this in Africa also at the administrative 2 level. Right, just to wrap up, and hopefully we have some time for discussion. So, I showed you, sort of Facebook and LinkedIn. I could have shown you Weibo, Snapchat, Google, anything that has targeted advertising has a platform like this. And it will also have an API, I'm pretty sure, just because they want to make it easy for advertisers to sort of, optimize large advertising campaigns, right? You get relatively real-time estimates. It's not as of this hour, but I think there's a lag of about like a week or so. At least when there's an internet outage, we typically see this sort of like a week later, all the estimates sort of plummet, sort of. So, but again, a week in most of international development is amazingly real time, sort of. Right? The data is anonymous and aggregate, right? Which I think is positive. We don't have individual level data, sort of. So I mean, there are other concerns, but I don't think it's individual level privacy. I mean, there are a lot of other concerns, but again, I don't think privacy is the main concern in terms of accessing, personally identifiable information. A lot of different features you can use for targeting, and again, sort of free of charge. It's far from perfect, right? So first I mentioned this sort of black box, right? If you ask me exactly how Facebook knows the country you've lived in, I don't know, right? I can speculate, happy to do so, but ultimately I don't know, right? Data is definitely not representative. I mentioned the biases, and the sort of that come with this. It uses a gender dichotomy, right? Only you're either male or female, right? And not everybody falls under that, but that's sort of what's used in advertising. Users patterns change over time, right? So that also, I mean, if you build up a model like a model that works today, it will definitely not work 10 years from now, right? Even if Facebook's still around, I'm sure users patterns will have changed by then, sort of. So you have to sort of, revalidate your model over time to see does it actually degrade or sort of. So it'll work a couple of maybe across a couple of months, maybe a year or two. Beyond that, I wouldn't trust it, right? There's no historic data available through these platforms, right? If you ask me, oh, that's great, I would really want to study what happened at the beginning of the COVID pandemic. Sorry, right? I mean, you missed a chance, right? Like sort of, so because you can only launch an advertising campaign today, right? So there's no historic data available. And then last but not least, there is a risk of misuse, right? I mean, in particular, you can identify vulnerable populations, right? I mean, different types of migrants are vulnerable, right? I mean, I guess the elephant in the room at the moment is Ukraine. I mean, we are doing analysis around Ukraine, right? I'm not sharing this here because, again, some of the findings might be sensitive, right, in terms of sort of population movement around that or sort of. And so there's clearly risk of misuse of some of this sort of data. Others more high-level reflections. I view this as a rare form of sort of data sharing, right, in quotes from academics. Right? And usually it's hard to have access to data from Facebook, right? But this is a form of data access, right? It's sort of, and the privacy research also uses sort of so. There's also a positive/negative thing for Facebook, right? I mean, it shows, there's value in all this data that Facebook collects, right? And Facebook themselves has an amazing initiative on data for good, right? I mean, like Facebook is amazing people working in this domain, sort of. So they're really trying to do great work with their data, but at the same time, it does provide a sort of whitewashing opportunity for them, right? Like sort of, right? I mean, sure, so they might be causing a genocide or here or there, but hey, look at all these other good things we can do, right? So I don't want to minimize that, right? It also creates interesting power dynamics. So, for example, we are working with the European Commission on migration, right? In particular within Europe, right? And so they see a lot of value in this, right? And so on the one hand, they're going to Facebook, hey, Facebook, please give us more data. Your data is amazing. On the other hand, of Facebook, you actually want to sort of regulate you and limit the amount of data you can collect, sort of. So I find it, I find it interesting to sort of say the least. And then last not least, but it's a great bang for the buck, right? Sort of. So it's very easy to collect, very easy to analyze. And so for capacity building, sort of, so like if you're new to sort of international development or sort of, so I think it's a great place to start. It's much easier to get started with than satellite imagery. Satellite imagery is also amazing. We're using it for other sources, but I think this is an easier sort of way to get sort of started. And then last thing, just so again, like, the work's generally motivated by, better data will lead to better decisions, right? So that's sort of general mantra of this sort of in this domain, right? But then, you always have to, is it really so, right? Like, for example, when you look at things like global warming, we've had data for a decade, 2 decades, I don't know, and it hasn't led to better decisions, right? So then there's always a question, we just need better algorithms and then we will eradicate poverty. Really? I don't know, right? Like, I mean, I'm hoping that better data will contribute to this, right? But I also don't want to be like naively say, it's all a data problem, sort of, right? But still, hopefully, we can at least highlight certain issues, right? Like gender gaps, we can monitor progress, right? We can sort of point some fingers, and hopefully that's helpful. But just the data that happens will definitely not fix those issues. Last slide, I promise. If you're interested in this sort of topic, just a quick bit of advertising. For a special track at ACM Goodity. That's a new conference. First edition is this year, where together with an amazing sort of program committee and colleagues, we are organizing a special track on this sort of topic. How can they use sort of social media data for humanitarian and development challenges? And so thank you very much, and hopefully we have some time for questions and discussion.
Great, thank you so much, Ingmar. That was a great, super interesting talk. There were some questions in the chat, and Max is on mute at the moment because he's got sleeping family members. I'm going to ask his question on his behalf first up. So his question was, he's wondering whether you often work with sort of undefined or informal geographic areas, particularly on things that could be quite small scale. And so his observation was that wealth in an area called, quotes, the Park in Nottingham would be sort of an anomaly against the surrounding inner city areas, that it's not actually bounded on a map specifically, and it's getting smaller as big houses get converted into student properties. So he's kind of got a question around, how do you think about the sort of scaling where you find these important areas that actually look distinct from other ones? And he was hearing that people are struggling with that in Africa in particular.
Yeah, it's a good question. So Facebook has different ways to target geography. So the easiest is through sort of built-in predefined geographies like zip codes, including in the US and in the UK and sort of Germany sort of. So apart from zip codes, you can drop your pin anywhere. You sort of say latitude, longitude sort of or so, and then the smallest radius you can provide is 1 kilometer. So that's the smallest. So there are 2 kilometers diameter, sort of 1 kilometer on either side. However, in practice, we've observed that this is not a sharp edge. So we've sort of done an experiment where we sort of run this into the sea, sort of, so, right, where you clearly nobody's living in the sea, right, on the, let's say, Boston coast or New York coast, sort of, or so, right? But even if you're like maybe already like a, let's say, a kilometer gap, sort of, or so, you still pick up some. So there's some sort of noisy edge around this, right? So in practice, that would mean, so if your area has like maybe 3-4 kilometers diameter, then yeah, it's definitely, you can catch it. If it's much smaller than this, it becomes tricky. I mean, you could still do a lot of overlaps and see if you shift this by 100 meters, if some estimate sort of changes, but that we haven't really done sort of. So if it's now an area close to a park, just a couple of buildings, I think it'll be tough. It might not be impossible, but it would require a lot of effort and sort of thought on how to really pinpoint this small area through these interfaces.
Cool. And I'm just going to ask one more on Max's behalf, but whilst he's still on mute. So he's also intrigued to know whether the use of the APIs that you're doing with Facebook actually are for or against their terms of service, and whether they actually care at all or limit any kind of rate of data scraping or programmatic access to the API at all here.
Sure. Yeah, good question. So my understanding of the APIs is yes, that is in line with the terms of service, because when you look at their sort of clauses around the data use, it all means it's sort of derived from, after you launch the ads, there are certain things you can't do with the data on click-through rates or sort of. So we never get to that stage, right? So I think it sort of falls through, it's a bit of a loophole, let's say, at the moment. There are rate limits, sort of, so there are different levels of access. You can sort of, once you have some, you can sort of apply for upgrade, so to speak, right? But even without the upgrade, you can do about 1 request every 10 seconds, like sort of, so. Yeah, and I mean, Facebook, they know this work. I mean, I've spoken about this work at their headquarters. They were even here at an event in Doha at some point. They're generally, I think, by and large, I think they're supportive, sort of, so, because again, it shows them value of their work, sort of, so. But again, in some things, I think they are rightly more concerned about potential misuse. In particular, sort of the whole migration domain is more sensitive, right? If it's like about gender sort of gaps, right? There's less direct potential for misuse, also politically or whatever, sort of, so. When it comes to migration, other topics, you could see how that creates more headaches, right? Sort of, so, and could be misused.
Great. And I'm just going to, as people put hands up, I'm going to call on them. And I think, David, you're the first one I see with hands up.
Thank you. Well, it was super interesting. I was wondering about triangulation of different sources. So if you were to train models with Google ads, for example, and Facebook ads, how different do the models look? And if you were to use different sources of data, is that one way of maybe getting around some of the biases that are available? Because I was thinking, well, even in amongst my friends, everything I do is everything I say here is anecdotal because I've not no familiarity with the data. But the way that Facebook is being used amongst people I know has changed dramatically in in the last 10 years. And my students, for example, don't use Facebook anymore. And I can imagine from country to country, the way Facebook is used and the frequency that Facebook is used is very different. Which groups of people use these tools will be very different. But all the models that you have are kind of constantly assuming that Facebook is the same. So you train models on data from one country, and then you apply it to another.
Yeah, no, excellent question. So we've done some work looking at Google data at the national level for these gender gaps, and by and large, they were very strongly sort of correlated and very similar. If you combine them, you get a slight boost. But if you had to pick one of them, at least at the global level, for countries where we have ground truth, right, and they're not missing at random, right, sort of, but where we countries have ground truth, Facebook predicts better than Google, sort of. Now, in other projects, we've looked, for example, with UNICEF, we've looked at teenage gender gaps, sort of, like how they use it. And for teenagers, of course, platforms like Snapchat and Instagram, which is also part of sort of Facebook, are probably more relevant, right? Or maybe now it's TikTok soon or so, right? And there are huge country-to-country variations, sort of, both in terms of Snapchat penetration and even the gender gap. I mean, I forgot that some countries, but in some countries you have like 5 times as many girls as boys on Snapchat or something, or sort of, right? Like, which doesn't seem to reflect general internet access, sort of difficulties for boys, but just sort of, I don't know, marketing, social norms, whatever, something around platform use or something, or sort of. So yeah, so no, definitely. I mean, I think triangulation is definitely the way to go. But if you ask me, okay, in this country for this problem, what's the best data source? I probably couldn't tell you up front. All I could tell you is all the other platforms can be connected through the same sort of general setup. For example, now we're looking at Contact here, right? Like sort of, so due to obvious sort of reasons at the moment, right? Sort of, so which is more popular in Russia, sort of, right? And again, you have the same sort of setup.
Thank you.
Vivian, do you want to jump in?
Thank you very much for this talk. My question is very related to David's, and you mentioned in your talk that historical time series data is really hard to get because you only get this idea a couple of years ago, or well, let me organize my thoughts. By now, you must have had this idea to collect data over time. And for example, with Ukraine, you saw this comment, you must collect the data. But the statisticians always tell us in order for time series to work, you need to keep the variables stable over time. And you just told us that Facebook is changing the algorithm. So even over the last however years you've been doing this, how many changes have you observed in the Facebook data? And even, if you were to decide to collect historical data now, does it make sense because Facebook is changing the algorithm so often?
Yeah, very good question. So we have been, for our collaboration with the University of Oxford on the sort of digital gender gap. So we've been collecting data now for, I think, 4 years or so, if I'm not mistaken, like sort of, so fairly regularly, some collections even daily, some other sort of monthly or sort of. So this is very, very aggregate, country level, men versus women sort of data. Now, at that level, we haven't seen any explicit changes, right? Like, so there's no change where Facebook would reclassify you as a man or as a woman or something at some point or sort of. So those numbers have been stable, more or less. I mean, there have been, the only variation is, for example, when there's an internet shutdown, it sort of drops. But other than that, it's just sort of natural, usage patterns, right? Facebook, might increase or lose market share, and that's sort of reflected in this data. Now, some of these derived estimates, right? For example, these are now inferred, like countries you've lived in. There we've seen changes February 2019 or March, February 2020. We were expecting one in February 2021, right? We think maybe every year that's their sort of cadence. For some reason, didn't come. Like we're waiting, we were ready, but it didn't come. Sort of. So there we've seen sort of two discontinuities for this particular attribute. For other attributes related to the interests, they change a lot. Like, I mean, I was collecting data, even before the Trump election, in 2015, 16, looking at what are people interested in, and can we predict maybe, and this was completely random, like from 1 week to the next, there was like a 300% increase and then a drop in whether you're interested in Hillary Clinton or not. And it made no sense. I mean, it didn't correlate with anything, you know, so basically we stopped. We couldn't understand it, why there were these sudden jumps. It was just didn't coincide with anything going on in the real world. So for these interests, yeah, the sort of they change even more often than you know, sort of once a year. But of course, the fundamental, you know, how people change with the interaction, you know, with the platform, that we can't control, but that will of course evolve, right? Like as you know, as David also said before.
We're almost out of time, but I wanted to squeeze in one last question, if I can, on my own. And it's really sort of picking up, in fact, on Vivian and David's comments. You were talking earlier about the kind of observation of, I think it was people from Venezuela and how they moved across different countries longer term after a particular kind of crisis event. Curious to hear your thoughts on like how a sort of slower moving but no less impactful thing like climate change and what that will do to migration patterns around the world. Do you think that's sort of observable, particularly kind of picking up countries where that climate stress is more pronounced at, you know, already, and whether you could start sort of seeing, yeah, we're seeing these kind of migrations as people, maybe particularly the more affluent people with access to resources, and therefore maybe more detectable in the current systems, start sort of making these conscious decisions to move themselves, their families in different ways?
I think, yeah, if at least sort of changes over the sort of 1-2 year time frame, I think should be observable, right? So in particular, so for example, even LinkedIn themselves, they share data with the World Bank. You can, if you search for LinkedIn World Bank, you should be able to find it. Otherwise, let me know where you see sort of year to year out migration and immigration of sort of LinkedIn users country to country, sort of also, right? And that you could already sort of maybe potentially look at, you know, whether from one country to the other there are sort of certain things, right? Of course, if you collect your own data, you can disaggregate it even more, like by sector, by gender, by education level, right? Are these now senior people or sort of junior people or sort of so? So I think I think that's possible. I think most of our work so far has been more at the even shorter time frame, like sort of, so let's say a couple of months, let's say, sort of humanitarian sort of things, right? Like again, now Venezuela, Ukraine, these kind of situations. But I think there should be a signal also in these platforms. Like again, the challenge would be historic data, right? I mean, for LinkedIn, you're lucky that they themselves publish some data. In other cases, you would have to sort of start your collection now, so that in 2-3 years you have some historic data to compare against.
Yeah, super interesting. If no one else has got any questions, I appreciate we've just run a little bit over time. But if there's any last questions, we can squeeze them in. And if not, let's please thank Ingmar again for this great keynote today. So good to hear that. It was a really interesting talk.